We're going to look at binomial distribution. And what we're going to do first is we're going to try to make sense of what they've given us for information here. So what this says is a binomial, it just means there's two terms. So it just so happens within this set of brackets, we have two terms. Anytime you have an operator that's like addition or subtraction, that separates terms. Anytime it's multiplication, technically that means that can be crushed into one term, okay? And then the distribution part just has to do with the exponent on the outside of that piece. So they've given us placeholders. A is a placeholder for the first term of the binomial, and B is the placeholder for the second term. And then N again is the placeholder for the how much you want to distribute them, the exponent to it. So before we get into this general formula of how to apply it, let's take a look at the question they've given us. They've given us a first term. So in this very first term, we can start to lay out what our placeholders are in terms of the question. So A in this case happens to be X. Not wonderful, still a variable, but they're not asking us to solve for the variable, they're just asking us to expand it. The second term, in this case, is a little more complex. They've given us a fraction, it's a variable that has an exponent to it. We'll leave it as is, but there's going to be a way we can actually make this simpler to work with. We'll just leave it just because we're trying to identify to start. Okay, and then finally the last one is the exponent on the outside that happens to be 4. The reason this is good practice, and hopefully it's relatively straightforward, is because this general formula is really a formula for plugging things in and then just going from there. So what we're trying to do here is they're asking us to find T2. So T2 in this case, they're saying T2 is equal to 8x, and we need to prove this concept. Okay, this is the tricky part in terms of that general formula. They've given us T2. In this case, the formula says T, which means just the term. They want to know what the term is, and they're asking for the subscript. That just means the term number. So if we were to put a large polynomial, and we have all these pluses in between, these are just placeholders, I don't know what they'd be. This would be our term 1. This would be term 2, term 3, term 4, and then they would go like that. And they would usually call this term n. In other words, depending how large it is, okay? Erase this piece. So when we take a look at this, there's already a bit of algebra, though simple, that we have to carry out here. That says the number 2. That doesn't necessarily mean r is number 2. It means that this together should equal that. In other words, r plus 1 is equal to 2. So I actually got to figure out what r is in this case. I can do that pretty quickly. That's a simple one, right? R is equal to 1. Ah, great. That was my last unknown for this general formula. So now what I can do is start to plug into this general formula. So it turns out, and I'll write them on the side again just so we have a better reference. A is x, b is a fraction with an exponent. Our exponent here, our n is 4, and r happens to be 1. So for our general formula, we have t is 1 plus 1, which is going to be 2. I'm going to plug it in like that for now. Our n value is the number 4, and our r value is 1. So the question here for a combination, have you ever heard them write it this way? 4 choose 1?
Yes.
Yeah, okay. So they're asking how many different ways can you choose 1 out of 4? Do you know the answer? This one's actually, if you know Pascal's triangle, it kind of builds from the outside, but this one ends up being actually just 4. You can only choose 4 different ways here. The next piece here is our A. So before I actually even go ahead and plug in A, and the reason I'm really doing this is because B is the one that's complex, is I'm going to leave it as an A, and I'm just going to deal with the exponent for simplicity. We'll do it like one step at a time. N, my N value, that's not a nice N, is 4, and we have to subtract 1 from it. Okay, so I'll do that, carry out that algebra in a second. And then RB happens to be whatever the R term is in this case. So RB is, what is R? 1. Okay, so I got that piece. I'll do a little bit of the simplification here. So we're looking for term 2, it looks like. 4 choose 1, that's actually just the number 4, so I can write it as a coefficient. This ends up being a to the power of 3, and this just ends up being b. I mean, we could write power of 1, but it's not going to change anything. Now we can do our second set of substitution. Our a value is actually x, so we're going to replace that value with x. And then our b value, which is going to be the tricky one here, is this number. So this number here I can rewrite. I know fractions are not a student's favorite all the time. So one way we can rewrite a fraction, I'm trying to think if actually this will be helpful in this case. I'm going to show you how we can rewrite it, but now looking at it, this version actually might be nice. Anytime you have this denominator here that has a variable that's positive, I can actually rewrite that as something like this, where we just take the negative version. That's familiar? Mm-hmm. Awesome. Okay. We can do that. We'll start it this way and see if we can piece our way through it. So our b happens to be the number 2, and then x squared. Okay. So in other words, we're replacing b with that value, we're replacing a with that value, and the rest of the stuff is just coming down the same. So we have a 4. Technically, our a is to the power of 3, and we're still working at term 2. Okay. So all I've done is just plug things in. I'm using the brackets to represent multiplication. Now we look across, t2 is equal to, what's nice about multiplication is it doesn't matter the order we multiply things in. We can multiply in any order and then work from there. I'm going to get rid of these brackets and I'm just going to write them beside each other. So we have a 4 multiplied by x cubed multiplied by 2 over x squared. I can split that up too. And in fact, I'm going to. This is like known as decomposition. I can write this into 2 sets of fractions multiplied by each other like this. I'm going to do that just to simplify what we're looking at. And maybe this will be too simple and you'll go, I don't need to do that piece, which is fine. But this can be helpful for reviewing something. 2 over 1 is just 2. So I'm actually not going to write it that way, but I am going to write this one as a full fraction here, x squared. I'm going to try to put together values that I can simplify. 4 times 2, I can simplify that. I know that that is going to be 8. Okay, and then I'll put these two together. I can make this a fraction, and the rules with multiplying fractions, the top times the top, or numerator times numerator, and denominator times denominator. So x cubed times 1 gives me x cubed, and 1 times x squared gives me x squared. Okay, now it's getting a little closer to that answer that you've given us. If we remember our exponent laws, that's it, and we end up with the 8x that they had said to us. So we did quite a bit there. Mm-hmm. As you get more familiar, you probably don't have to break the steps into every single step, but it's good to have a general overview anytime you go back to look at it, like, oh yeah, that's what I might do in this step here.